One of the most disappointing moments in my life was when I realized that as cool as they look, giant robots just are not practical war engines. Our topic for today is space warfare, and was selected by a poll over on the channel's Facebook group. This makes for a tricky topic for a couple of reasons. First, we have never had a military conflict in space, so it is hard to speak of it in any way but theoretical. Tactics change constantly in warfare, and are hugely dependent on what the technology of the time is. We don't know what the available technologies will be, and they ought to change over time too. So with all those uncertainties, I cannot realistically come into today's episode saying this is how war will be fought in the future in space. But we can look at a lot of the common concepts. We also have to look at them briefly, since this is the 5th iteration of the script and every version had different topics, and none of those 4 came in at less than 30 minutes. So I'm electing to a fast approach to touch on topics rather than going into deep detail. We can always come back and look at some of them in greater depth down the road. Categories are inevitably arbitrary, but here are the ones for today. Number 1, stealth. Number 2, range. Number 3, weapons. And number 4, defenses. You probably noticed I didn't include a section on whether or not we would ever have wars in space, or on the morality of war. We do sometimes cover ethical concepts on the channel, but my goal in doing so is only to ever set the stage for folks to ponder it on their own and draw their own conclusions. So I reserve it for when we are in an alien landscape, exploring some technology or concept that is not familiar to most, in which case it is handy to lay out a lot of the basic concepts and concerns others have raised on the topic to get the wheels turning. The ethical arguments involving war are hardly unfamiliar, and in spite of spending about half of my adult life in the military, and a good portion of that in frontline combat units, I can't say it granted me any special new insights. Since I don't have any, and since everyone is already familiar with the topic, it would seem quite silly to spend what little time we have today on that. That's not entirely true. I do have some special insights. For instance, there are a lot of rules to warfare, but for some reason they almost always are rule number 1. There's a lot of rule number 1s. I decided to start with stealth to get it out of the way. This one is simple. There is no stealth in space. I will attach an article from our friends at Project Rho that goes into the nuts and bolts of that, but this discussion is so well worn over, with nobody ever coming up with a way that doesn't violate known laws of physics, that there's actually a law on it, Nikel's law, and a couple corollaries. We will still do the basic walkthrough though. First, and most obviously, we never know what weird new tech someone might make or when someone might find some new physics, but for this episode we are keeping it in the realm of known science. I am not going to say stealth in space is impossible, but I have never heard of a workable scheme, and I don't know anyone who has. Everyone wants to have stealth because it's very handy. I mean, that is rule number 1 of combat. Don't let the enemy see you. Stealth is without doubt the most valuable thing in war. So people want stealth, but there are some reasons why this isn't viable. First, we have the engines themselves. And putting it kind of bluntly, a spaceship's rockets are about as covert and subtle as a pack of clowns parading around with drums and megaphones in a town plaza during the daytime. They are literally the least unnoticeable thing there is. They are giant explosions. The sorts of engines we use right now to get stuff into space could be detected by the sorts of equipment we have right now all the way out on the fringe of the solar system. The kinds you need to move the big ships we often see in sci-fi might be detectable at interstellar distances, and that's assuming people haven't gotten better detectors, which they would. Since we know how to build much bigger and better telescopes than we have right now, we just don't because hauling them up into space where they work best is too expensive. The cleverest way I've ever heard of for trying to conceal that would be to have all your exhaust coming out as neutrinos, and in tight beams you could aim off at an angle behind you in the direction of nothing. How you would do that was not explained, But even then, one tends to assume if you can make all your thrust neutrinos, and tightly beamed like that, then people have probably also gotten much better at detecting them too, so I doubt that would help much. But it wouldn't make much difference anyway, because we still have 3 other ways to pick up a ship. The second is the light it blocks. If something passes between a star and you, it blocks that light, and there are a lot more stars than we can see with our naked eye. They also can't just mimic the light they are blocking, since that won't be the same for 2 different observers. If you just happen to know where everyone is who can see you, you could emit a laser at each that replicated what they were supposed to see, but that's hardly foolproof and wouldn't work if you didn't know where all the monitors were, for instance. If you could get around that, you would still have the third problem, which is that you are giving off infrared heat. Everything you do on your ship warms it up, and that heat can only escape by radiating away. We can pick up radio signals out in the outer solar system light hours away that are only 10 or 20 watts. Your body is giving off more than that right now in infrared. Now you could maybe run cold, drifting in with all your crew on ice or no crew at all, just a computer doing minimal tasks. Heck, maybe just one big chunk of metal moving at relativistic velocities, a relativistic kill missile or RKM, which we will talk about more later, but basically a big bullet. The problem is, space is not a true vacuum. Even interstellar space tends to have about 1 million hydrogen atoms per cubic meter, and your missile is moving at hundreds of millions of meters a second. Even a missile only about 1 meter wide is going to slam into around 1 quadrillion hydrogen atoms a second and be emitting hundreds of kilowatts of radiation from that. So your sleek and stealthy missile is only as loud as a radio transmitter for a major metropolitan network. The faster it goes, or the bigger it is, the brighter it is. Plus, it will still block starlight. So again, stealth is not really an option in space without some new physics-breaking technology. Now that doesn't mean you can't use other types of stealth, like pretending to be someone else, or having someone sabotage your enemy's sensor networks, but that's a different story. Also, there is still going to be a maximum range at which someone can detect a certain thing. Maybe you can see a big starship's engines around another star, but that does not mean you could detect a cold-running, sleek and stealthy missile that far off. And range, our next topic, is a weird one. We will often hear people talk about the maximum range of a weapon, for instance, and that can get confusing. For instance, most pistols are no good out past 100 meters, but what we mean by that is what distance a decent marksman using normal ammo can hit a human-sized target at without lots of special conditions aiding or hindering him. You can obviously hit the broadside of a barn a lot further out because bullets don't magically fall out of the sky after 100 meters. They can easily travel kilometers before landing, and while all sorts of things about the gun, the ammo, or the air can alter its expected trajectory a bit, they generally stay pretty on course. There's no air in space, and one assumes we will get increasingly precise with our weaponry, so that's not the source of maximum ranges in space. People often get irritated by energy weapons like lasers having some listed maximum range because a laser should keep going forever, which is not actually true, but for practical purposes more or less is, because they do have a maximum range from something else. Space is big. Really, really, really big. So even though light moves really, really quick, it still means it can take quite a while for the light from your target to reach you, and your laser to reach them. They are no longer going to be in the same place since they are presumably moving. Now that's not a problem in and of itself. If you know how fast someone is going and in what direction you can aim for where they will be when your shot arrives. But if they've got fuel to spare, they can be accelerating, and while no one ever shows it in science fiction, even though those ships always seem to have infinite fuel, the first and most obvious defensive maneuver any ship's captain would learn would be to have his ship constantly flicking around in random directions, just a little side thrust for a minute one way and then another picked at random. So if your target is 1 light minute away, it will take a minute for light to reach you and a minute for you to send back, and that means that ship has 2 minutes to accelerate. If it did at just 1 G, it would be anywhere inside a 70-kilometer radius sphere centered on where you expected it to be. If it were 2 Gs, it would be 140 kilometers. If it were twice the distance and 1 G, it would be 280 kilometers. Of course, if the ship were 70 kilometers wide, it wouldn't matter. You could aim for its middle and still hit. Though I wouldn't suggest shooting at something that big, since taking pot shots at a warship the size of a country is probably picking a fight you don't want. That's rule number 1 of combat. Never pick a fight with anyone bigger than you. Actually, even fair fights are a bad idea, so you're best off always picking on someone smaller than you, and it's still a good idea to cheat any way you can. Always having an advantage in firepower is without a doubt the most valuable thing in war. So the bigger a target is, and the slower it can accelerate, the further away you can hit it with lasers. Don't assume big means slow though. A ship twice as massive needs twice the fuel to accelerate with, but it does have twice the room for fuel. It probably has more too, since it can get away with not doubling everything else. You do not necessarily need a second coffee maker on a ship just because you doubled your mass, even if you doubled your crew, which you probably wouldn't need to. Obviously, you need at least one coffee maker, since no sane military commander would ever go to war without a ready supply of coffee. But the key point is big doesn't mean slow, and again quite possibly the reverse. It will still have a larger effective range you can hit it at though, because the range is always based on how fast the ship is and how big it is. For instance, some robot drone the size of a baseball only needs to move maybe 10 centimeters to seriously decrease your odds of hitting it, meaning it is hard to hit even a light second away, even if it can only do 1 G, and it might be able to pull off thousands of Gs. This does not mean smaller is always better though, and we'll look at that more later on. Other weapons have different sorts of maximum ranges. For instance, a missile can have a guidance system that will guarantee it hits, so long as it doesn't get shot down or run out of fuel. Running out of fuel is not really about distance in space though. It is about being able to catch up to whatever you are trying to hit, and still having some fuel to change directions to intercept it if it is dodging and to avoid being shot down. A ship could run right by you and you might still be unable to hit it with your missiles if it is trucking along at 1/10 the speed of light and your missiles don't have the fuel to get to that speed themselves. That's even more true if you were moving the opposite direction when you fired them, and now you need to make up another 1/10 of light speed just to get back to where you fired them. So range is a pretty variable concept in space warfare, and depends on the target's characteristics as much as the weapons themselves. Moving on to weapons, we've got tons, even without going to some of the cooler but less scientifically realistic ones. And I'll still go through some of those too. We've got lasers, we've got masers and grazers, we've got railguns and nukes and missiles and kinetic weapons and antimatter and particle beams and even exotic particle beams and black holes. But more importantly, we have some specific classifications of weapons. Smart versus dumb, light speed versus slower than light, and ones which can circumvent intervening space. Now in this context, a normal gun would be classified as sublight and dumb. It doesn't circumvent space either because it does need to pass through it and anything in it. Alternatively, a classic sci-fi teleporter could presumably teleport a bomb right to a location. Here I'm using circumvent space to mean both something that could just leap from point A to point B that way, or which does not have to worry about being weakened or disrupted by things in the way, sort of like an armor-piercing round can go through armor. I should note, on things we'd think of as guns, that the barrel of a gun in space doesn't serve the same purpose in a vacuum as in air. Rifling and barrels primarily exist to let the bullet spin and stabilize its flight through air, though it also helps to avoid the issue muskets had of the ball not fitting the barrel to give a good seal. Long barrels on space weapons just serve to give the projectile more room to accelerate. I mention this because when we think of space warfare, we tend to assume everything being shot that isn't energy is a smart weapon. We can make computers mighty small, and sticking a small guidance package into every bullet would seem like a good idea. The problem is that while we can make circuits that can withstand accelerations that would turn you or I into chunky salsa, they still can't handle the same amount of acceleration one solid chunk of iron or uranium could. So you should always be able to produce dumb rounds that come out faster than smart ones, and that should hold in the future too, even if we can make smart weapons able to handle a lot more G-force. That means you can have a much shorter barrel with a much faster reaction time too. It's not something we normally have to think about at the scale and speed we do war at nowadays, but if I want to shoot a gun at something, I have to turn the barrel to point at where I want to aim. A long barrel is going to tear itself apart if you turn it too fast, and any lag time caused by the weapon cycling up and shooting is going to add to that distance your target can dodge by accelerating. That said, and that's mostly a concern for point defense, which we will talk about in the next section, by and large you want smart weapons wherever you can have them. You can't make a laser smart though, and it is your fastest weapon. We also tend to assume every projectile is going to have a warhead in it, but it depends on what sort of speeds we're talking about. Very fast weapons don't benefit from having chemical explosives in them. Their collision energy is already way higher than an equal weight of explosives would have. Relativistic projectiles, things moving at a decent fraction of the speed of light, don't benefit from even a nuclear warhead aboard. They are already carrying around energy comparable to antimatter. If you are not familiar with the kind of yields antimatter has, a normal bullet that included a little bit of antimatter inside it would explode like a nuke. Amusingly meaning that you could make a pistol or rifle that fired a nuke with every trigger pull, but you'd be inside the blast radius. So much smaller bullets with much smaller amounts of antimatter in them would be smarter. Normal bullets for firearms tend to weigh a few grams. 1 gram of antimatter combining with an equal amount of normal matter is a few times more potent than the original atom bombs used at the close of the Second World War, while a billionth of a gram is more on par with a modern hand grenade. However, while hitting a nuke with a hammer or a bullet will just damage it, not cause it to explode, antimatter is the exact opposite. It doesn't require a complex process to make it detonate. It requires a complex one to prevent it, since it explodes the instant it touches normal matter. We usually figure on using magnetic bottles to contain antimatter, but those probably cannot handle very high G accelerations. Your average bullet undergoes thousands of Gs for instance, and bouncing off the ground tends to be a lot more than 1 G too. So while on the surface antimatter is both the perfect explosive and the perfect rocket fuel, that is only true if you can not only produce huge amounts of it cheaply, but also can store it safely and use it safely. If firing it out of a rifle or cannon barrel caused the magnetic bottle to fail to contain it, you just blew up your gun. And given the yields involved, not just your gun, but everything within several miles. That's rule number 1 of combat. Never use a weapon that's as likely to kill you and your allies as it is the enemy. That's why claymore mines have big notes on them, reminding you which way to point them, and why biowarfare has never been popular with militaries. Now a laser is the fastest weapon, which at close range means it never misses either, but at a distance it can miss since it can't change its course. This also applies to variations on the laser like the maser, which shoots microwaves, or the grazer, which is a gamma ray version. Missiles can change course so are better at long ranges. They are also not vulnerable to mirrors. No mirror is 100% reflective, and they normally only act as a mirror for certain ranges. For instance, we don't even have a material that can reflect gamma rays yet, while the normal mirror for microwaves is chicken wire. Hit a mirror with enough juice and it will get destroyed. Hit it with a frequency it doesn't reflect, or doesn't reflect as well, and it will get destroyed. Pepper the enemy with debris to damage those mirrors, and they will get destroyed. But they are still a decent defense against lasers, so missiles have an advantage there too. Now an energy weapon doesn't have to shoot photons. A gravity-based laser would go just as fast if you could figure out how to make one, but you don't need to go at light speed. 99.9% of light speed is just about as good, and you could have a particle accelerator, a particle beam or particle projectile cannon, which will get the job done against a mirror too. They are susceptible to a magnetic shield though. Key concept here is that a mix of weapons is a good thing, even if some get you less bang for your buck. Now there's a lot of sci-fi weapons we are skipping because they either are just made up or not based on known science, but one I did want to mention that's at the fringe of possible is meson beams. Neutral pions, a type of meson, interact with normal matter about as weakly as neutrinos, which as you've probably heard could slide through a light-year thick sheet of lead uninterrupted. Neutrinos don't make a good weapon for that reason. A neutrino beam would just go right through someone's armor, but they'd also go right through that person or ship too. But neutral pions decay, quite quickly too. They're the shortest lived pion and live for only about a 10 millionth of a nanosecond, which means normally they die before they even get outside of the atom they originated from, but we can detect them by slowing down time when we make them, by making them go very, very fast. Now with a big enough accelerator, you should be able to speed the mesons up so much that they can cover real-world distances before decaying, and they normally decay into gamma rays, so you can bypass people's armor with something like that. Now a particle's half-life is not an accurate timer where beams are concerned, even if they form the basis of the very accurate atomic clocks. Not all those mesons will decay at just the moment they pass through the target, and the further away you are shooting, the less likely it is a given meson would decay inside the target. But if you are at close ranges, or you can make them at close ranges, or you've got a target that is just impenetrably armored, it is a potential weapon that can circumvent armor, akin to teleporting a bomb inside an enemy ship or opening up a wormhole inside a bunker. Wormholes, should we ever be able to get them to work, are obviously excellent weapons too. Also a good reminder to sci-fi authors. A lot of super technology made for a book or movie or TV ends up breaking suspension of disbelief when people start realizing what other purposes it can be put to, and just about anything can be weaponized. Micro black holes are another type of circumventing weapon and one we discussed before. Black holes have a lifetime, according to Hawking, and the lighter they are, the shorter they live. Ones weighing only about a ton would only live a few nanoseconds, for instance, but would be a lot smaller than a proton and would fly right through basically anything, then die, releasing energies that would make the biggest nuke we ever made look like a firecracker. You can time these a lot better too, by controlling the mass and speed you shoot it at, and it's not something you can really stop because it's so tiny but has so much inertia. They are not really black though. They'll be bleeding off huge amounts of radiation on the way there, so you might be able to knock one off course with a very powerful and very narrow laser. I'd laugh at that, except you basically need those kinds of lasers to make these sorts of black holes, Kugelblitz black holes, in the first place. So if your enemy has the tech to make them, you have the tech to deflect one, but it would still be a nigh impossible target to hit in order to do that, and it will go right through any type of armor. Though of course it can still miss, and it can still be dodged. As we move into defense, we can see another obvious rule number one. The best defense is not getting hit, so distance is your best defense. Of course it is also hard to beat your enemy if you stay far away, so that's not always an option. If you have to get into a slugging match, it does pay to have armor, and this is a case where size does matter. Let's say I have armor that's a meter thick on a ship and uses up 10% of its total mass. Now I clone that ship, only twice as big, in each direction. According to the square cube law, I should have 8 times more volume and mass, but only 4 times as much surface area. So meter thick armor on it now only uses up 5% of the ship's mass, not 10%. Maybe I use that 5% for more engines and fuel, maybe I just use it for more armor. And again, I can probably get a bit more than 5% since some of my systems didn't need to go up proportionally with the mass. As mentioned earlier, I don't necessarily need 8 times the crew or coffee pots just because my ship is 8 times heavier. We also have point defense. While you can use reflective hulls to handle laser attacks, and magnetic fields around you to help against solar radiation and particle beams, they won't do much against missiles and bullets and big explosions. Armor helps with that too, but ideally you blow stuff up before it gets to you, and the sooner you hit it the less damage you take, as it will spread out in a cone, the wider the better. A quick note there, We think of explosives as going off in a sphere, but in practice, if the exploding thing is moving fast, it is going to be shaped as a cone, as all the material keeps moving forward even as it explodes in a sphere in its own rest frame. That means anything you blow up is still going to go off like a shotgun blast, so you want to let it have as much room to widen out as possible so most of it is not hitting your ship, or at least is spreading all over your armor, not at just one point. Now, a laser is a great point defense weapon since it can't miss at ranges you need to worry about shrapnel, though there's a lot to be said about high-speed equivalents to flak cannons, or just having a ton of small debris near you. A nuke is a pretty good way to deal with volleys too. Always a thing to keep in mind, if you've got a point defense system that can reliably shoot down a missile a second, your enemy isn't going to politely feed you one every second. They are going to send 10 in at the same time every 10 seconds instead. Lasers aren't necessarily ideal for that scenario. You might have relativistic slugs coming at you that have some maneuverability, and you can't target them till they are 1,000 kilometers out. That is not a lot of time, and they are going to need a big, powerful hit to shred them up enough to spread out so their shrapnel doesn't tear you apart. I usually laugh when people refer to nukes as a defensive weapon. They are in a diplomatic sense, but not when the fighting starts. But in this case, they can be. You know you can't target the volley of inbound objects fast enough with lasers, so when you first pick them up, you fire a nuke toward them and intercept them further out with a device where precision strikes don't much matter. Of course, it would be nice to have the classic sci-fi shield or force field, but we don't have any paths to that in known science, just magnetic fields and the like. But we do have the option of an even more classic shield, the old school big sheet of metal on an arm. Such a shield can be thicker than your normal armor because it doesn't have to be all over. You move it to interpose with your enemy. It's also out at a distance, so when it starts getting shredded, the stuff that gets through is still going to be deflected and scattered, and you've got some distance for it to scatter. This is space after all. Your shield doesn't have to be right next to your ship. Your arm could be hundreds of kilometers long. You can also use that to maneuver with, as a way of saving fuel for bouncing around in random directions, since you can just tilt and roll with the thing, or things. That still takes energy, but less of it, and it could be mostly recovered, as with a spring, and it's not costing you any reaction mass or leaving huge jets of flames when you move. As I mentioned at the beginning, there's a lot of stuff we bypass today. There's never enough time, but I think we've covered the key concepts important to considering this topic, which is always our goal here, to set people up to know what the right questions are to ask and where to go to find out more. Our friends at Project Rho are a great source for more on spaceships, including spaceship fights. For those of you more interested in looking at infantry or ground combat aspects, I'll also recommend millsf.com, operated by my friend Author Bill Frisby. He has tons of articles discussing a ton of topics on that subject. I'll link both in the episode description, and while they are amazing resources for sci-fi authors, they are also a lot of fun to read if you just like the sort of in-depth approach we do on this channel. Next week, we will be beginning a short series of related videos on colonization. As mentioned, today's topic was picked by the Facebook group, and the close second was to take a look at early colonization of other solar systems, sort of as an extension on last week's fun collaboration on colonizing our own solar system with Fraser Cain of Universe Today. When I was thinking about it though, I realized that while we often talk about the more technological and mechanical aspects of things, like spaceships or asteroid mining or planet bases, we never spend much time on what life on those would actually be like. We never talk about the day-to-day life on them. We never talk about how you would govern one. We never talk about what life on a colony ship would be like. And I think we can and should try to give that a look, because it's a common conversation when people discuss these topics, and there are a lot of misconceptions I think we can address. It's also a long topic, so we will break it up into 3 phases to set the stage. Looking at life on a remote colony in our own solar system, then life on a colony ship, then our early extrasolar colony. Make sure to subscribe for alerts when those episodes come out. And if you want to discuss this topic more, or get to suggest topics and vote in the polls we pick them from, make sure to come on over and join the Facebook group Science and Futurism with Isaac Arthur. And if you enjoyed this episode, make sure to like it and share it with others. Until next time, thanks for watching and have a great day.